To everyone, and these are the question number 16 of Reneet 2026. So I'm going to do this particular question. Consider two circuit A and B, each having two resistors. One of them has a positive temperature coefficient of resistance, positive alpha, while the other one has a negative temperature of coefficient negative alpha, as shown in the figure. The current through this circuit are denoted by IA and IB at initial temperature, and the resistance of the two resistors is R naught. As the temperature is increasing, the correct option that describe the variation of current in these circuit is. So these are the circuit which are given. So are four options are there, which telling about in the first options there are these are telling that IA increases while IB decreases. Second, both IA IB remain constant. Third, IA remain constant and while IB increases. Fourth, IA decreases while IB increases. So this is the question, and we are going to do this. So I'm going to take a particular white page for it. So step by step we are going to do this. First of all, if we are analyzing the circuit one, first of all, this is the question number 16. Question number 16. First of all, if we are analyzing the circuit A, it is a series combination. It is a series combination. Series combination. So in circuit A, when we talking about circuit A, the two resistors are connected. The two resistors connected in series. In circuit A, the two resistors in circuit A, the two resistors are connected in series. Are connected in series, and the equivalent resistance the equivalent resistance R equivalent A of a circuit A is the sum of individual resistance, is the sum of both the individual resistance, is the sum of the individual resistance, sum of individual resistances. So we have given R equivalent A and sum of independent resistance R naught 1 plus alpha delta T plus R naught 1 minus alpha delta T. So expanding and simplifying the equation, this equation, if I am expanding this equation, if I am expanding and simplifying the equation, then get to be R equivalent A is equal to R naught plus R naught alpha delta T plus R naught minus R naught alpha delta T. So this will be just going to cancel because positive and negative are opposite signs. So we get with R equivalent A is equal to 2R naught. So we are getting with this, since the total resistance is 2R naught. Since the total resistance to R naught is independent of temperature. Is independent of temperature. Is independent of temperature change delta T. The total resistance remain constant. Then the total resistance remain constants. So first circuit we are getting that the A circuit is going to have a remain constant. This particularly A circuit is going to have a constant temperature because the resistance, because the temperature change are not changing at that level. So because of the Ohm's law, I is equal to VR. The current IA then remain constant because the resistance is constant, that way remains constant. If we are talking about the circuit B, now analyzing the circuit B, which is a parallel combination, which is a parallel combination. So circuit B is a parallel combination. So in circuit B, two resistors are connected in parallel. The equivalent resistance is given. Equivalent resistance is given as equivalent resistance is given as R equivalent B R1 dot R2 R1 plus R2. Substituting temperature dependent formula. So if we are substituting the temperature dependent formula, substituting temperature dependent formulas for the resistances, SIST for the resistances. So we will get the R equivalent as B is equal to R naught 1 plus alpha delta T dot R naught 1 plus 1 minus alpha delta T. This is closed. So here we have R naught 1 plus alpha delta T plus R naught 1 minus alpha delta T. So it get to be R naught square 1 minus alpha square delta T square 2 R naught. R naught and R naught going to cancel from here. So we will getting R naught by 2 1 minus alpha square T square. It means delta T square. R naught square alpha square. As the temperature increases, delta T is greater than 0, and the factor in the question given that delta T is increasing, so the factor 1 minus alpha square delta T square is going to becoming less than 0, become less than 1, because something is getting here which is increasing square always it will be getting less than 1, causing the equivalent resistance R equivalent B to decrease. causing the equivalent resistance to decrease, because now the overall circuit resistance decreases, circuit resistance drops, the current is increasing. The current is increasing. So from the above, the R equivalent is decreasing, and R equivalent if decreasing by the Ohm's law, we have I is equal to VR. So if I decreasing, R decreasing, I would be increasing. So that's why in the circuit we have the in the circuit B, the IB is increasing while in the IA remain constant. Option number 3 is the most suitable answer of this particular question. I hope this is understandable to you. Do like, share and comment. Thank you.